What's up, everybody? Welcome to the I don't know, we're just coding. I've already been coding. We're doing some compiler stuff, so why don't you join me with some compiler stuff? How about that? How about that? This is fun to play with. I've been doing this for a little bit. Let's write our announcement. Be sure to check out all of my videos. This is the 55th now, part in a series on compiler dev. So there's tons to get into. Let's write our little announcement on the Discord. These announcements go out every time I go live, and if you're in the Discord and asked to join the notice, you'll be pinged every time I go live and never miss another glorious session of coding. How about that? How about that? All right, we are officially live. But yeah, be sure to join the Discord, links in the About section or wherever you are used to getting them. We have a ton of fun here, and see, GMOS just said live when, and now I'm live. So shout out to GMOS for getting this whole thing going. Guaki52 says hi. What's up, Guaki? I've seen you before around here. Today's a little different. I don't have a fresh Emacs. I've already been coding. So you are joining me halfway through. How glorious is that? There's a little bit of a fix me to do here. Okay. Whoop. Had to get that out of my head. We're live. We're going to be doing some compiler dev today. We're going to be going over machine IR stuff and doing some assembler ourselves in the form of machine code. So we're going to be turning these forms of instructions into actual machine code so that we can get object files directly. For example, object dump -d on this out file from our compiler. You can see that these bytes here are exactly what we are writing here. You can see we have OXB8. Do we have an OXB8? What do we have? We have an OX48. There's quite a lot of those. Am I crazy? OX48. I guess that's the Rex bit. The actual opcode is 89. That's what's going on. There we go. Ruark says, good evening. What's up, Ruark? It's super Maddox says, why not just use JavaScript? Heard it's a great language. Yeah, why not? Why not? PR's welcome. PR's welcome. But yeah, so we're going to be doing some assembler because we don't handle all the instructions we need. For example, I think it's pretty easy to run into that if we do like function arguments many. We're also going to be running into machine code stuff because I'm also working on that. Oh, that one worked. Nice. So we have function arguments many, and we can take a look at that. Yep, that looks like summing 8 integers to me. A bunch of moves from... That's cursed. This isn't right at all. We shouldn't be having move absolutes in here. So that's a little wrong. I don't know how this is happening, but there must be an invalid opcode going on. That's causing it to be... So OXB8 plus an encoding gets us to... Well, I wonder if we're just missing the Rex prefix in these places. Move. So this is also missing an OX66 prefix, it looks like. Yeah, this should have an OX66 prefix, which I don't know if I still have the Intel manual open. I guess I should have checked on that. I do. The OX66 prefix, they'll probably call it the 66H prefix or whatever, is somewhere around here. Software can still use the operand size 66H prefix. Yep. Can you tell me what the... Oh, it's right here. It's right here. So you can see that the 66H prefix, this just tells you when you can use it. Can you tell me what it actually is? It will not. Well, I can tell you what it is then. It's somewhere in here. Basically, the prefix OX66H or OX66 or 66H, right? Just 66 in hex, tells in 64-bit x86 64 to lower it to a 16-bit operation, because by default it's a 32-bit operation, and then the rex prefix turns it into a 64-bit, the rex.w prefix specifically. We're also missing the destination register encoding here, kind of entirely. So hold on. You can see that 8-bit instructions, 1 byte, has a different opcode, B0 versus B8. But B8 is shared by the 16, 32, and 64-bit versions. So why don't we have this prefix? I mean, all I have to do is this. That should do that. Okay, missing prefix, done. But we're also missing the optional rex prefix, because it's possible that the top bit of the destination register, if it's a 64-bit only register, is set, and that won't be encoded in these 3 bits that we have here. So we need to actually set a rex prefix if that happens. A lot like up there. And then we need to do the same thing here. Oops. And in here we always have the rex prefix. So we're just going to set the W bit to true. And think about, where would this extension go? Where would this bit extension go for the opcode? It'd probably go in register, but let's... So the R bit. Let's take a look at the manual of the rex prefix, can we? Oh, I did a search. Need to go here. Rex prefix. It's coming up here somewhere. Here it is. And then there should be the bits. Okay. Extension of the SIB index of the mod RM SIB or opcode reg field. So this is the one we need to do. It's actually the B bit. Okay, that's the last one. And we need to set that only if the top bits of the bits of this register are set. The encoding. Molly the man says hello. What's up, Molly? How's it going? We're doing some assembly fixes, it seems. Still move absolute. We are getting the correct register now, it seems. Is that even correct? Are we moving to RX10? Is that what we want to do? So we have, yeah, we have moved 40 into R10. Where are we at? So we have moved 40 into R10, but it's becoming a move abs. Why is it becoming a move abs? OXB8 plus RD encoding plus IO, which is 8 bytes. 1, 2, 3, 4, 5, 6, 7. That's 7. How is there only 7? What's going on there? Molly the Man says, I'm good. What about you? I'm doing okay. It's another day. I'm having fun coding. And I just opened a brand new cold drink. Ah. Nice and cancery. Gmo says, good boy. Move immediate 64 to R64. So the rex.w, I guess I just have to go look at the move encoding now, because I'm getting confused about it. Move versus move abs. What is move absolute even trying to convey? So what bytes do I have in a row? 49BA28. 49BA28. So that's the B8 thing. So I'm looking for B8, these things. Yeah, move immediate 64 to R64. This is what I want to do. And it says rex.w plus B8 plus RD IO. If we take a look back at the instruction format, rex.w indicates the use of a rex prefix. The ordering of the rex prefix are discussed, blah, blah, blah. The rex prefix goes directly before the opcode if you don't know. We then have B8 plus, and then RD. What is RD? RD plus RD indicates that the lower 3 bits of the opcode byte is used to encode the register operand without a mod RM byte. In non-64-bit mode, blah, 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 in 64-bit mode indicates the 4-bit field of rex.b, and opcode 2 bits 2 through 0 field encodes the register operand of the instruction, plus RO is applicable only in 64-bit mode. Moldy the Man says, is Intercept type-safe language? It's 2023, bro. Only type-safe languages. Yes? What is... I don't know what you're asking. It has a type checker. It will fail to compile if the types that you have declared in your program do not match how the program is operating or written. You can't assign, like, a struct to an integer, if that's what you're talking about. It's statically typed? Is that what you're asking? Rourke says, I hope every language is type safe. Yeah, right? Rourke says, I think you mean dynamic typing. I think, yeah, maybe that's what they're talking about. That would make more sense. So RD means D-word register. We get ES, DX, BX, SP, EBP, ESI, EDI, ESP, EBP. That's just a copy from there. Okay, that's confusing. Oh, and then that's just a copy from there. Very confusing. And then this has the rex.b bit set for all the 64-bit registers. Very, very simple. 1, 2, 3, 4. 1, 2, 3, 4. So then there's 8 bits. So we have the rex.w, the register encoding, and then the 8 bits. Why is it move abs? Maybe I'm freaking out about nothing and it's correct, and that's just what they're telling me is the thing. So let's do like this and use object dump on a.exe and disassemble main. Perfect. See, it doesn't have move abs, but it also doesn't do an 8-byte immediate move. So why are we doing an 8-byte immediate move? That seems ridiculous. What? mcode immediate to reg. We're assuming the immediate is the same size as the destination register. So maybe it's wherever we call immediate to reg. which I guess technically right now is in the bad I cell. Which would be immediate to reg. And you can see we're passing in if the size of the type. So when we do integer arithmetic, it's 64-bit arithmetic. That makes sense, but it's not an immediate. We're saying if type size of instruction type. So if the immediate type is very large, we're just going to assume it's very large. Okay. Molly the Man says, what's the difference between statically typed languages and dynamically typed ones? Oh boy. Let's go to examples, right? And then let's, I already have Intercept highlighting, that's POG. As you can see, we have a return type and parameter types, right? So in static typing, you have to declare a type. You can't just say, there's no type. At some point, you have to declare a type. Yeah? In dynamic typing, you can also declare types. That's what's confusing. But in dynamic typing, you have one box. And that's like dynamic typing means everything is in the same type of bin with a label on the front that says what it is. Static typing means everything is in a very specific sized and layout bin, yeah? And the size and layout of that bin are determined by the programmer's type declarations. Or type deduction / inference. So in static languages, everything has to have some sort of type. But compilers are smart enough these days to know that if I go A is assigned to 42, even my compiler is smart enough to go, oh, A is an integer equal to 42. Or if you say like my string, right? You can say my string is equal to this string. And it will just automatically say, okay, this is a byte array of this size. That's type inference. This is easy. You can have this in static languages. Because A still has a type declared. It's just type of 42, right? This would be the same thing. Right? Right? Whereas in a dynamic language, everything goes in the same box. So in Python, for example, if you have 42 or you have 42.8888888889, they both go in the same type of box. They're both just somewhere. But this one has a 0 and this one has a 1. And then somewhere else there's a table that says like T0 is equal to int and T1 is equal to double and stuff like that. And then this gets you size of is equal to 8 or whatever it's going to be. You can do a line of, right? And then ... etc. The type is declared each time it's used. And also in dynamic typing, you really can't compile anything that's dynamically typed unless you add a ton of runtime checks. That effectively in C would equate to like if thing.kind is equal to type.int, right? Or something like that, int type. Then do this, else, and then it's going to be like error, type error, runtime type error, right? Everything's going to be wrapped in this, in a dynamic language, just from you accessing A, right? It's going to have to do all this and say, what type is it? How do I treat it? What do I do to it? And it's going to do all that at runtime usually. Whereas a static language, everything has to be known at compile time, which means the program has to contain everything that it needs. And also for efficiency and optimization, having types explicitly stated makes things better. And also for program correctness, it's really been found. For example, that's why TypeScript is so popular, because JavaScript doesn't have declared types, and that means that you can write a function that adds two things and then use it on strings, and that's like, that doesn't make any sense, right? So it really helps the programmer convey intent and also ensure correctness, as far as I know. Static typing. And it's needed, static typing is needed to compile things. You can compile dynamic languages. They just compile down into something with a runtime. Like Lisp, you need a runtime to run it, even though it compiles down to machine code. Because it has to access the global environment and check types and do things like that. Does that help at all? Hopefully that helps. Molly the Man says yes. Legendary. Let's figure out this weird old bug, shall we? So we're doing an 8-byte encoding. Why are we doing this? We're only doing this because the type is 8 bytes. But if we know the size of the time, so interestingly enough, we almost want for immediates to do this no matter what. So what if I just did this? Because whether it's an integer literal or not, it's still an IR immediate. And because it's an IR immediate, we know the number. It's immediate here. So I don't think we actually need this check at all. I think we can just do this. Yeah, there we go. I fixed it, boys. Jangtron, thank you so much for the follow. Where are we at? So I fixed that. That works. That's poggers. And presumably... it doesn't work yet. Something's very broken. I wonder what it is. Okay, that's fine. Why broken? How broken? And why? It looks like we're subbing from RSP and then never adding to it, which is something I'm worried about. But if we just move RBP RSP, that won't matter. So it looks like that's our solution for not subbing. And then we pop RBP because that's the only thing above it. Okay, so that should be fine. I don't know why that failed. We're gonna move on. We got stuff to do. Something I found interesting that I'm running into now for machine code, right? Is that when we're looping over the unlowered machine code, so basically the machine instructions, here's what's the idea, right? We have like an IR, which we can look at. Give me that glorious IR printout. We have this IR, but none of these are actual machine instructions. Like this isn't, oh, an x86-64 store into, right? These are kind of instructions for an abstract machine, something that could be implemented on x86-64, but it's not necessarily a mapping one-to-one for instructions, right? Which isn't ideal. Not ideal. Especially when you're trying to emit instructions for x86-64. These aren't the best view to have of things, right? It'd be preferable if you could just have things that map much more closely to real machine hardware instructions. Because, like, what is copy? What is load? How are these actually implemented, right? So what we're trying to do, as you can see here, is lower this even further into machine instructions. And each of these machine instructions is much more closely related, or will be much more closely related, to the final output. For example, you can see op 1080 here. What that is, when that says op 1080, I know it's confusing. It's not, I promise. Basically, that's this MIR opcode for x86-64. So there are opcodes for each architecture, for each ISA that we want to support. And these are actual machine instructions we can emit. Call, jump, ret, JCC for like jump if zero, jump not zero, etc. Push, pop, not, or, right? These are all actual things we can emit. OX display error, thank you so much for the follow. I like your name. But yeah, so these machine instructions actually map very closely, and they start at offset, guess what, OX420. That's right, they start at offset OX420, because where else would they start, right? Where else would they start? They have to start at OX420. Right? So op 1080, if we take a look at this, I know I'm jumping around a lot. Whoops, a lot. I believe it's a move, as you can see. Op 1080 is a move. So this move instruction is moving from what looks to be register 8 into an address register R15. I believe that's the base pointer, and a -8 offset from that. So it seems that this is much more close to an actual hardware instruction, and it's almost close to assembly even, where if this said move, and then this -8 moved in front of this R15, you'd kind of be like, oh, this is starting to look like actual assembly. That's exactly what we want. We want it to match much more closely to the hardware ISA. Rather than having this move, right, be represented by, where is it, a store. What is a store? Store doesn't actually mean anything, right? But in x86-64, we know what move means, and we know what these operands do. And even these operands are a little too low. I don't think they should be registers yet, but bear with me. Bear with me. We're working towards it. One thing you will notice is a big issue, though, and what I was going to talk about. See how this copy mentions M26? But M26 is actually back here in this other list that we're building this from. So we're trying to lower this generic list of machine instructions into an actual x86-64 list of machine instructions. Buffer OXAA55, what's up? How's it going, bootloader? You like them magic bites? But yeah. So the idea is that eventually all of these will be op something, and then we can just emit that code. Or we can just ignore anything that we don't know how to emit. Like, for example, we don't necessarily need to emit immediates anymore and then use a register temporary for them. we're actually going to be able to remove a lot of the immediates and have them inlined into instructions, much like these offsets and stuff like that. Anyway, we have to resolve this thing where a machine instruction is lowered, but then the reference to that machine instruction that has been lowered references the unlowered one, which is not good, right? Who do we got? We got someone in the Discord? We got 2 people in the Discord, Mig and Yaz. What is up? What is up? Thank you so much for joining the Discord. I appreciate it. What book do you recommend for compiler construction? I wouldn't know. I haven't read any. No, I'm kidding. I have read a lot of stuff. Just whatever catches your interest. If you're looking for just names of books, then like I think it's the someone just said it like yesterday in the Discord. I can't remember what it is. You might want to search for book, because this has been a question asked quite a few times. This about OS dev. It's somewhere. I'll have to find it. It probably wasn't just the other day, or it's in a different one. Basically, there's tons. The Dragon book. I wouldn't recommend starting with the Dragon book. At some point, the Dragon book might be good. If you're very experienced. Rourke says crafting interpreters. That's the one. That's the one. I don't like that book at all. Lox is not a language I enjoy, and I don't enjoy Java, so I had a really hard time with crafting interpreters. But I've looked at crafting interpreters a lot. I haven't read through the whole thing page by page, but I've looked at different sections of it while I'm implementing the compiler. And it's definitely got really good information and solid data, which is really rare in compiler books. Most of the time it's like, we are building a web of things. And they never describe what a web is. And you're like, what is a web? And you're like, I guess it's a list or some structure. What? Is it a Yush? What's up? Highland. Hi, is it a Yush? What's going on? Worth compiler construction. I haven't read that one. Maybe I have. I don't remember. I just do things. I'm your friendly internet e-clown. I'm not a professional. Who knows what I'm doing, much less. So we can lower calls to name. Why is call not being lowered into a new? Okay, let's work on this instruction selection a little bit. So currently, it's a little bit confusing because things are happening in parallel. There is one version of this where we have this MIR value x86-64, and this contains everything that is needed to emit an opcode, either through machine code or into assembly, for x86-64 in this compiler. It has the instruction form, and it has the instruction opcode. Not the opcode, but the actual enum that lets us know which instruction it is, right? And then if it's an immediate, it has an immediate and tells you it's an immediate form, stuff like that. This is happening once in the ArchX86-64 backend right now, right? So we are going through and calling select instructions at some point. And then from these machine instructions, we're going through and actually building the assembly and emitting the object files, right? The generic object file, which then gets emitted as xcoff and elf for Windows and Linux, right? Isidore says, good, how about you? Waiting for PR reviews at work. Nice, that's always fun. You're like, well, I'm either gonna be fired for my horrible code, or, maybe it'll be fine. Where are we at? But yeah, so that's what's going on there. We're basically just taking the form and emitting instructions based on that. But then also there's this other pass going on that is currently just being printed out. So all this printout you see is just this other pass, right? It's just these. And this is select instructions 2. And this is actually lowered. It's machine IR that's been lowered from IR. And that has these different, it doesn't use the MIR value x86-64 at all, right? It doesn't use those. It's this other thing where we have IR, we go to MIR, and then we're lowering MIR here, right? Even further. So this is when we should actually like select proper instructions, and we're doing it in code because reasons. What are we doing today? Machine code stuff for the compiler. So we're doing mx64 call. We make copy, and then we push call. I don't think we need to make a copy here. I don't think this is anything we need to do. I think it needs to be much more like IR call handling. Yeah, all of this is much more important, I'd say. All the count registers used in function, align stack pointer before. Yes. So all this stuff we would do there, do here. But do it in a different way. So instead of encoding the operands specifically for x86-64, we kind of want to do it generically. Each machine instruction that's been lowered can do this. We have a tail call. Each instruction that's been lowered has its IR instruction that it's been lowered from as an origin. So we have all this data that we need for this stuff. What's cogent epilogue? I'm a little worried about that. Interesting. So we're going to have to do that. To do cogent epilogue. Perfect. Now, the idea that basically we're going with, I guess here's the thing. Okay, we're not going to deal with this call because I just realized I jumped away from something. I've got such bad ADD. Not really. I haven't been diagnosed. That's a lie. Yeah. So I don't think I need to handle calls. I don't need to fix the handling of calls because the handling of calls isn't the problem right now. The handling of references not being updated is the problem. I gotta lock myself down a little bit here. MIR operand. So we have this MIR instruction, which has operands, and what we'd like to do, what would we like to do? Oh yeah, we'd like to keep track of one of itself. I think we have to do that like this. We're gonna say lowered. And we're gonna say an architecture lowers a generically lowered MIR instruction. Store the arch lowered MIR instruction in the generic instruction so that we may properly update references going forward. Cool, huh? So MIR instruction lowered. Now what we're going to have to do is anytime we actually lower something is set that. So everywhere I create an MIR instruction here, in select instructions 2, what do we get? A bunch of call stuff like we do in emit instruction. Yeah, that's fine. So when we use mir make copy, for example, we should say call lowered, but not call lowered. It's going to be instruction lowered equals call. Right? Yeah. And we don't even need to make a copy. This is a mess. So let's do this here. XOR 0 lowered. Nope, I did it wrong again. Instruction lowered equals XOR 0. But here's the thing, it doesn't because there's actually another machine instruction. So if we omit this one, then we want to set down here. This is a little bit complicated. So basically, here's the gist. When we make a reference to something, we want to reference its value. So XOR 0 is not the value of anything. It doesn't produce a value. It produces a value of 0 in that register, but that's not important. The actual value we're curious in is the move. So that means that we would like the move to be the lowered version. So maybe whatever we push at the very end, well, that won't necessarily be true. Okay. Again, we have another XOR 0 and move, and another XOR 0 and move. Wonderful. For IR store, we have a store instruction, and the store instruction is the lowered instruction, so that should be fine. For return, it's going to be the same. For a copy, it's going to be the same. For a jump, it's going to be the same. And for a conditional jump, we should never have to deal with referencing a conditional jump instruction. So I'm not, because when would we reference a branch conditional? We should never reference a branch. If we do, it should be a block. So this should never be an issue, really. So same with all the JCC instructions. We don't really need to reference a jump ever, so having this happen doesn't need to happen. In any case, we're going to make it the test instruction in case it needs a value for some ungodly reason. And then we can see all the unhandled instructions. Lovely. Because I'm halfway through, as I said. You are joining me. Well, it did compile. What happened? Oh, yeah. So now, when we make a reference, this is going to be in machine IR. When we make a reference operand, we should follow machine instruction until it's no longer lowered. I need this thing. And then use that. Use the lowest possible version. Okay, that didn't quite work, so let's think about why that didn't work. 26 is a register. Okay. Why did that not work? Because we're doing make copy here and not doing anything about it. Okay. This is literally just going to be something. I don't even know what it is. We're just copying whatever we have. And something, not even something lowered. Instruction lowered needs to be equal to something. And then push something into the machine instruction. Some machine instruction. Okay, not quite. Not quite. Copy M21. M21 is a call. Can we do the same thing to a call? We did do the same thing to a call. We said instruction lowered. Call. And we are using make reference, as far as I know, to get references. MIR op reference. So what's happening there? While instruction lowered, instruction equals instruction lowered. Outvalue.ref equals instruction. So I guess the idea is that they don't have their lowered set. I guess it would be what's going on. Can we print that as a thing? Please and thank you. What do we got going on? Did we print anything? Hold on. What just happened? We're supposed to be printing a pointer somewhere. We didn't print a pointer anywhere. That's a little suspicious. Unless I'm just not seeing it. Inverted Connie Narco says, thank you so much for the follows. I appreciate it. Yeah, I don't see a pointer being printed out anywhere here. Which is a little worrying. Is this code not being called? So you would think that it would be. Instruction lowered equal sus code. So we're selecting instructions. Ooh, I wonder if it's here. Okay, it could definitely be here. So this copy that's probably what it was, because these are probably pre-colored for return. Or just because we've done register allocation already. Nope, still wrong. Why? Why do like this? So M21, just to be clear, is a call. And M21, this first call. Why are there two calls? Oh, there aren't. That's a function. Okay. There's a call. And it does have, right? It is in a register. So we're just copying it through. I think we can't do this yet. To do, enable this once we wait until after ICEL to do RA. Okay. So I think the problem with this is because we're doing register allocation before instruction selection, which is like a real messy thing to do. Perfect. This is just complaining that allocate doesn't actually exist in this implementation, and it's true, it doesn't. We still don't have these updated, and the reason being, I'm now realizing, is that we were just copying them through, were we not? Yeah, so what was happening is that we weren't handling these instructions, but they were being copied through without their operands or a new instruction being made, really. So that's definitely not the way to do things. At least if we're gonna, it should be explicit. So let's think about this further. It says MIR allocate isn't handled. We can change that. How is an allocate handled normally? Not normally. How was it handled before? Quite simply, it looks like. It was literally this. So the equivalent of this, we're going to create an MIR instruction. We're going to make a new one, and it's going to be an MX64 Leah, it looks like. Is that correct? Oh, yeah. This is an allocate. We're going to have, I'm losing my voice. We're going to have an operand, which is the offset. And this is going to be equal to an immediate operand. I guess we also need the base register. And then I'm just going to set the instruction form like I was before, because otherwise I'll never get this. And this is going to be mem to reg, I guess, would be what it's classified as. A stupid question. What's an MIR instruction, Lens? It's not a stupid question at all. It's a very reasonable and valid question. An MIR instruction, we can take a look at its definition. An MIR instruction is a machine intermediate representation instruction, which is a mouthful, which is why we say MIR, right? And basically, it's a machine IR instruction, is all you have to think about it. And it's basically, I'm saying basically a lot, but it's equivalent to an IR instruction in the data that it represents, sort of, in that it is a bunch of instructions with an opcode / type and operands that it operates on. It's just a better view of the data for code emission and among other things. Does that make any sense? So it's basically an IR instruction, right? Which is just some kind of arbitrary like IR add or IR subtract or IR multiply, right? And these all have operands like left-hand side, right-hand side, right? So you add left-hand side and right-hand side, and those are other IR instructions, right? So if you had like IR immediate 8, IR immediate 8, and then IR add 0, 1, right? Something like this. Then the result of this is 16. Indifferent 02 says, I'll be taking a class on compiler design next semester, so it's interesting to see the stuff you're doing. That's awesome. Good job getting ahead. You'll definitely have a better view if you can understand what's going on. Ah, thank you. What's it used for? Well, like I said, it's just a better view of the data for code emission. So, for example, I don't know if you were here before, but in the Arch x86-64 backend, it used to be way more complicated to emit code. And I know this looks complicated, but it's really not. Emitting code is now as simple as looping over the machine instructions and then just calling a function based on a number in it, right? With its stuff. It's as easy as this. It becomes a switch statement with a function in each one. This is easy. This is amazing compared to the crazy stuff we had before, right? It also allows us to do optimizations on the machine instructions themselves. So, for example, in the IR, there's no mollac, right? Mollac, which is multiply and add product to accumulator. So if you're doing A plus B times C, that is a mollac instruction and can be one instruction on x86-64. But in the IR, we only have multiply and we only have add. So this is going to be 2 instructions in IR, but only 1 in MIR. And then there's other examples like compare or branch conditional, right? Branch conditional, 1 instruction in the IR, but multiple MIR instructions. So the machine IR maps much more closely to the hardware ISA, whereas the IR is kind of a made-up ISA. Okay. Just got to answer a text here. Indifferent says, you sound very humble, something that's kind of rare for programmers these days. Thank you, I appreciate that. But yeah, that's an MIR instruction. It looks like it's not needed, I promise. And in the current form, it's not really needed. And it never is needed because we did code emission straight from the IR for a long time, right? Another reason for having the MIR is so that you can have one structure that you can then define patterns for. MIR pattern, right? And this will be a way to convert one or more MIR instructions matched with a pattern, i.e. certain opcodes, order, operands, etc., and convert them into other MIR instructions. And once we can do that, then you can just define a bunch of patterns that say when you get an MIR allocate, actually turn it into an MX64 thing. But if you get, and then you can start doing things like, oh, if you get an add with an MIR mul, right, with an MIR mul operand, then you can say, oh, what we can do is turn this into a mul-ack. Does this make sense? So you can start defining patterns to match on the machine IR and then map them to actual machine instructions that correspond to those matches. That's what we're doing eventually. For now, we're kind of hacking our way through, right? So mem2reg is an address register, an offset, and a destination register. And we have RBP as our register. I'm just copying from this append MIR thing. Our immediate is a negative I64 from the offset. And this, again, is going to be the origin. Isidius says, makes sense. So MIR is a better representation of IR instructions. Sorta, yeah. I think IRs are like blocks, add mul, etc. Do IR instructions to machine instructions in x86-64 backend, or maybe I think I've got it opposite. Yeah, I don't know. Basically, MIR instructions contain IR instructions, but just a different view of them. So if we take a look at an intermediate IR instruction, right? You can see that it has all these different specific values based on whether it's a conditional branch or a static ref or an allocate. And in each of these values, there may be another instruction or blocks or things like that, right? So these other operands, right, to this branch conditional are kind of just hidden, and it's not clear how many operands each type has, and it's not clear what they're present or what they are, right? Like this has 2 block operands and a reference operand, but that's not clear just by seeing, oh, cond br. And if you were trying to match any instruction that had 3 operands, 2 of which are memory and 1 of which is a reference, right? Then you'd be like, oh, hey, 2 blocks and a condition, we can match that. But if you wanted to do that for IR instructions, you'd have to go through each of these values and validate that pattern for each of these, which doesn't make sense. All you really need to know is what are the operands and what are their types. So the MIR has just this list of an array or vector of operands, right? And these operands can just be easily accessed by index. So you can say, get me the 0th operand of this machine instruction. Actually, how many are there? Actually, what type is the second operand? And then you can go to each operand and say, oh, it has a kind, and these operand kinds are defined here, where you have a reference, a register, an immediate, a block, a function, a name, or the maximum, right? So these are the actual operand types that can be passed to a machine instruction. Hopefully any of this is making sense. Top Clean says, hi, on line 997 you paste a dash is normal. I don't know. I don't even know what file you're referring to be honest. I've been jumping around here. Are you talking about here? You talking about the negative sign? Top Clean says yes. Then this is, yep, meant to be negative. We're converting an unsigned integer into a signed integer, and then we're making it negative. because the offset from RBP is negative that we want to access. Oh, okay, sorry, thanks. No problem. I enjoy little things like that. You'd be surprised how often people actually catch bugs like that. Looks like R64 is what we assume for the result. And then, yeah, it's just like that. Okay, so now we have to add these operands to the allocate instruction in order. We have the address register, the offset, and the destination register. And then we want to push this machine instruction into the MIR for final use. Let's just double check everything here. We have a LEA, which is a address register and an offset. And then we have the destination register, which is just instruction result 64-bit. Okay. It's 64-bit always because it's a pointer. Well, that's close. Assertion failed. Index is greater than or equal to instruction operand count. That seems like an invalid assertion. Am I crazy? Hold on. Where was that from? Machine IR. Yeah, we... That's backwards. It's taken from here. This is why. When you assert something, you want it to be true. When you if on something and then return an error, you want it to be false. Okay, there we go. It's saying instruction selection doesn't handle the add MIR opcode now. We can deal with that. It definitely doesn't. So how do we handle add up above? The classic case. IR add. One of these, huh? Okay, so we're gonna have to get the size of the register based on the origin type. That's fine. We're actually gonna have two vector pushes here. An add, and then a move. And we're gonna have two instructions, which is an add. This is gonna be an MRR make new, MX64 add origin. Ooh, that's another thing I didn't set up above. Allocate origin. Why are you mad? Bad. Oh, that's right. This is an MIR. I have to do it the other way around and say instruction lowered equals allocate. And say instruction lowered equals move. And then I should say the origin of this is probably the same as the origin. That's probably what I'm missing up here too. Is that the allocate origin should be the instruction origin. This is a move, move, move. Okay. Isidiush says progress. Yes, we are making progress. I know it's not obvious with these types of things. We have a bunch of operands we want to do. We're going to have register operands. 3 register operands. But 2 in each. Okay. Okay. So we have MR op register. And we would like to find the left-hand side result along with size. And we want to add the right-hand side result. So we want to add the left-hand side and right-hand side. We may want to make these references instead of registers. So I want to reference am I doing here? I want to reference what? An MIR instruction. To reference an MIR instruction of the left-hand side, then it should have a machine instruction, right? Because it's been presumably already emitted. So its machine instruction is actually what we want. We just want a reference to that and then the right-hand side. This means that we don't actually have to have registers assigned or anything. And hopefully we can follow the lowering properly if everything goes well. So, where are we at? Instruction left-hand side, right-hand side. We add those, okay. I think that's fine. And then we move. We want to do a register to register move. Interesting. So we should probably have the instruction form set just so if we need it, we have it. Same with the add, that is fine. Presumably it's register to register. I guess we don't technically know that as of now. We can determine that based on these operands and what they actually are. I think this will work. Yeah, I think this will work. I am curious what happens. Subcommand failed. Context mir. Did I leave append MIR in here? I did leave append MIR in here because I'm not done. So with the move, I think I'm going to lower it like I have been doing into the registers just because that will make it easier. So a register to register move is going to be quite simple because it's going to be this. And it's going to be the right-hand side result into, and the size. Into the origin result. And then we push those two. So right-hand side into result, and then left-hand side, okay. How are we doing here? Hey, progress! We are actually referencing the proper things now. Poggers, that's poggers. That's very good. That's a good step. That's a good step in the right direction. 1078's return, I believe. You can see all these move and stores get and copies, they all get lowered to the same move instruction. So it's just move and Leah over and over. It's pretty good. R15 is RBP. Craziness. This is looking better and better. Then we have a call instruction. Very good, very good. Okay, and then we have all these immediates. What are all these immediates used for? Are they used at all? I don't think we need to actually emit immediates, as far as I know. I think they can be represented entirely as operands. But I think that'll require special handling everywhere. This is going pretty good. It'd be kind of nice if we could print these out, but that's going to be difficult. We're going to need like a function pointer or something. Can we get rid of this last comma? Why is that? I don't know why that's bothering me, but that is bothering me. How are we doing this? /B to remove last comma. We're literally using backspace. That's quite interesting. Quite interesting. Is that really the last thing that will print? So if we break here, then the last thing we will have printed is a space. And if we don't break there and we break here, the last thing we'll have printed is a comma. That should work. Why is this not working? See, that's odd. It should be removing that stuff and then doing a new line. Maybe /b isn't supported in this format. I don't know. It seems like that would work. I guess we can just do the trick. Right, and say if if j, this is the loop variable, is less than the operand count, and the operand count must be at least 1 for us to be in this loop. If j is less than the operand count and the next operand, which I guess would be base plus j plus 1, which I guess can also just be j plus 1, or not j, but the offset, so operator plus 1. Okay. And then I would like to see that that has a kind that does not equal none. And then I'd like to print a comma, please, and thank you. And a space, because I guess we don't need a space because we print a 1 first. There we go. Poggers. I don't know why that was bothering me, but that was. Ekedza and Paidzrice, thank you so much for the follows. I appreciate it so much. Poggers, this is going really well. Or at least better than it was. Okay. Cool. See, these won't actually be emitted as code. I don't think we need to do anything with these. But where are they going to be used? See, we're not using them properly because they're immediate operands. But we shouldn't be like loading this into a register and then loading the register into a thing. We should just be, the immediate should just be loaded. But maybe we should wait until, until we have pattern matching for that. Because then we can just match on any move. But then if it's already lowered to registers, it's not going to work. So this is definitely not, we're going to have this be references, aren't we? Are we going to have this be references? I mean, at some point, we're going to have to lower this to something that looks like this, because this is what we need for assembly output, is something that looks like this. But this seems too low because we're relying on registers being allocated, which is not the lowering that should be happening yet. We should not be worrying about register allocation. So anywhere we have a reference to a register, we may want to take a look at that, which is all these moves I just did, I know. So if we have a register to register move that we want to do, how would we best say that this register is actually a virtual register? I guess that's why Sarade did the vreg approach. That is not a bad idea, the vreg approach. That would require a lot of changes right now, but it wouldn't be too bad. Okay, anyway. I'm getting antsy. I kind of want to write some more assembler. Can I take a look at something? Do we have we have add. I do want to do multiply, but I also am a little bit scared. I could try a reg to reg multiply, which hopefully would make things like arrays be able to actually work. Because for indexes into arrays, we need the multiply instruction. And currently it's just saying instruction selection is complaining. Because of this, yeah. Okay. But yeah, so eventually the idea is that we will be able to wait to allocate registers until we get to the actual machine IR. But at the time of lowering it into x86-64, we may already have registers allocated. I think we will already have registers. Well, no, we can't, because at least not at the time of instruction selection. Stodlab says theme. It's in my GitHub. I'm sure you can find the links where you normally find links. And if you just check out my GitHub-aruni and go to emacs.files, it's a repository somewhere in here. Yeah, this one. You can find my theme here. I'm using the Lenser theme. I wrote it. It's got not much handling for third-party packages. It's not like a Protosilos package, but it does have some. And it tries to be easy to add things to if you really need to. But it does handle like iSearch and mini buffer and escape prompt and compile mode and bookmarks and tab bar and buttons and links and stuff like that. But yeah, there's how you can check out the theme. Where was I? Yeah, so basically we have an MIR. At what point, that is one thing I'm confused about. At what point does it actually become, do we have registers allocated? Because if we want to lower this into like an MX64 move, we kind of need registers. Otherwise, what is this move doing, right? It could be working on virtual registers, which is like whatever the result is in this other MIR instruction. And to do that, the thing is that would be hard because we have a register to register move, but what we actually want to do is it Yush? I wrote it. 2023 lens after landing on the moon with a self-programmed rocket. Lamau. That's really funny. Okay. Here's the thing. Here is the thing. When we generate the machine code, currently we're doing it after register allocation and a bunch of stuff like that, which probably isn't smart. Yeah? Probably not. So I think, what if we were to move allocate registers after the machine code lowering? That should be fine. That shouldn't cause like major issues in any way, shape, or form. At least conceptually. But it will right now, clearly, because we won't have any of these registers. So register allocation is going to have to go through these machine instructions and say, whatever register you have in here, if it's a virtual register or like the result of another machine instruction that you actually want, because for example, R15 is hard-coded. That's RBP. We know the base pointer is going to be the base pointer. So that can stay. But this R1, why use racks here? Why are we using racks here, right? It's not clear from this machine IR why R1 is being used. Why is racks being used in 1076? Whereas if we look at the code, the assembly code, it's very clear why racks is used. Oh, Jesus, this code gen is not great. So, as you can see, racks is used because we loaded 10 into it up here. But that hasn't like happened here. So why are we pretending that that's happened? There's nothing in this immediate 10 that says I go in R1. So we really need to fix that, right? We just want to say reference this immediate 10. So maybe it needs to be a reference. Maybe it needs to be a reference. And where's this move? This was like a regular one. What's the IR look like after the immediates? Oh, hey, we're good. Remember those pointers we were printing out? We're getting them now. I don't remember where I did that. I should probably find that, huh? I'm just gonna not grep find. I want grep. Regular grep. %p/n. Okay, didn't find anything. Can you search the parent directory? Didn't find anything. Okay, it must be, must need escaped. //n. Okay, what about the percentage? Does that need escaped? I never know with grep. Everything always needs escaped. I can't find it. That's odd. That is odd. Oh well, I'll find it at some point when I'm looking through the Git and committing stuff. So many changes. Here it is. Okay, there we go. Fix that. Okay, now we're looking for a move instruction. This is a store. So let's look at the IR. That's what I was doing. We have a bunch of immediates and then there's store intos. Okay, so in this store, we can use RBP, that's fine. But this result stuff is not really ideal. That should be a reference. And the reference is going to be to what? Whatever machine instruction the address got lowered into. I don't know. That seems a little funky. We'll see how it goes. What has happened? I don't see any. Why does this look so different? What have I done? I don't know what I've done. But that does look quite different. But these don't. But these should be store into. Why aren't these store into? So we're probably not storing into that particular thing. We're probably storing into a name. Well, storing into a name is fine, but then that would mean we don't have a register here. So it's probably just coming from somewhere else. And I am pushing store. Yes. Yeah, that is odd. So for this move, instead of address register, we're going to say, we're just going to shorten this too and say address. Then operand machine instruction, please. Offset is 0, destination is... See, this is complicated because this is just our own destination. So this is, we can't really reference ourselves. There we go. That's starting to look a little better, huh? So now you can see, again, not up here. It's not looking better up here for some reason. But down here, we are starting to get it where we're moving from 1116, which is actually just a register to register move, into R5, which means that we'll eventually be able to collapse this into moving from R5 into the offset from R5 of 0. I believe that's correct. Because what we're doing in the code is most likely a move into itself. That's this thing here, I'm sure. Because right after it is Aaliyah, off of the base pointer, -8, into R6, which is 1 over R5, aka R10. Yeah. Well, that's getting better, but maybe this isn't perfect, because we do want this to be a register. And right now it's a reference. And at some point, I guess we can lower that. But it'd be ideal if we could just have a register reference a machine instruction. I think that's the virtual register approach. Let's take a look. Okay, Sir Aid worked on something like this a while ago. Let's take a look at his stuff. He's very smart, and it's been a few months, but it's worth it. So, for the MIR, you can see he has the similar, he didn't get as far. Oh, he did, because he used the all binary instruction types. I see. Here we have the operand types. Yes, yes, yes. He used a bundle operand. That's quite interesting. And then a machine operand has a kind, it has values. And then the instruction has operands. Okay, this is looking very similar. What was I looking at? The virtual reg. That's right. So, make this even bigger. So it looks like each machine instruction, each MIR instruction, has a virtual register. How are those assigned? Create MIR instruction vreg, which is given a virtual register. Okay. And this just calyx a machine instruction. Pretty natural. Function machine instruction counter. So the virtual register looks like it's per function. Interesting. So MIR functions are a thing? What? Or is he just putting machine instructions within IR functions? That's probably what's happening. Which is a little messy, but that's fine. So we just have some counter that gets bigger. And presumably that starts at vreg min. Okay, let's try it. Because I'm already sort of doing something like that, I've realized. I just didn't call it a vreg. Make new. Yeah, see? So I have these counters that are used for architecture specific stuff or not. My Loudy says, yo, Lens, I'm a bit late. That's okay. No problems there. No problems. We are still going good. Sure. So we can have regular stuff. See, these numbers are affected by this. So what if these are just virtual registers? If that's the case, it would be really great if the virtual register also represented something useful. So maybe ID I want to keep. And maybe virtual register is something different. So, with this machine instruction, here's our issue. We want a register, but the register should be like R1102. But the problem is that 1102, while it does uniquely identify this machine instruction, we can't find this machine instruction in any other way than to loop over all the instructions and check each ID, which isn't what we want. We want this ID to be an index. Wasn't it an index? So we have a function mi counter. So each function has a certain amount of machine instructions, clearly. So let's look at how we changed the intermediate representation in his branchicles a few months ago. It's just a vector of machine instructions, okay. Is that it? That's it, okay. So a vector, you actually could use an index. So where's the IR function? Mi counter, counter for machine instructions. So when we create a new IR function, that's what I want to look at now. IR underscore function is what it's going to be called. What is this counter? Counter is vreg min. Okay. And then presumably, when we access, okay. This is starting to make sense. This is starting to make sense. It's just going to require things to change a little bit. So I'm just thinking, so when we make a new instruction, we want it to have automatically, ideally, a virtual register assigned to it. So if I go here, I want like a register descriptor or whatever that says yeah. We're just going to call it reg. It doesn't even have to be virtual. It's just a register. Right? I'm trying to think, what should this be set to? Obviously, it should start at vreg min, wherever it does start. So where does that counter go? Let's think about this. When we have a machine instruction and we're making new ones, we're making new ones into different vectors at different times. So it's as if the vector itself kind of determines the ID, because we want the virtual register to be an index I kind of just want to make this be a number, but I don't know. We're going to do it. We're going to just have it be a number. So I want this to be an index into the thing it's being added to. And to do that, we should just be able to say it equals mer.size and then push it. I guess it can be a size t. I don't know why I'm freaking out here. We can make it smaller if it really matters at some point. What is mer.size? Okay. So what we really want is this type of thing. Every time we do a vector push, really a lot of this needs to be moved into like preprocessor definitions. So we could have like mir push and then have mer move, and then it could do this automatically. I don't think that's the worst idea. Even though it doesn't save a ton. I think it's worth it. I don't know why I did that. Okay, so it's going to be something like this. mir push, mer move, and then everywhere there's mer and move, but then also we don't want move. This should just be mi, and we don't want one there. Yep, I'm gonna switch back and forth. Hold up. There we go. And then Egglet's gonna freak out. Cool. Now we have mir push. And now one thing I would like to do is a query replace on vector push mir. I guess this can't be a query replace. It's going to have to be like a regex query replace, because we're going to need a group here. Do I need two? Why is this not matching anymore? I feel like it is matching, it's just not showing me. So replace that with mir push, mir /1, right? I want to replace it with the thing. Replace 0 occurrences. Well, I would really like you to not replace 0 occurrences. Can we get one where I have a match? Okay, so I have a match. And then at that point is where it breaks down. Even if I do dot star, which is interesting, because dot star you think would just match anything. Am I still not in query regex replace? That would be pretty funny. Yeah, I wasn't. That would help a lot. Oh boy. There we go. This is working now. Ugh. Yes, 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 yes. Thank you. 20 occurrences. Okay, we're getting better, we're getting better. So now we have mir push. So now we should have virtual registers. So when I print them out, can I print out these vregs now? Let's just do it here. Cool. I didn't add a space. It worked pretty well though. So now you can see we have an index into this vector. Ooh, not here. We have an index into this vector. So now, can mir push be a function that takes in an mir vector in a machine instruction? I think it can. Which I know is a little wacky, but just trust me. Yeah, I think this makes much sense. Not query replace, just replace string. Thank you. And then I'm going to define this in terms of the machine instruction stuff, of course. Okay, mir push. Wonderful. And then this can be defined in machine ir.c. Cool stuff. Cool stuff. And then we need to use that when in machine ir.c itself. Instead of vector push, we need to use mir push. And I think we can just go through kind of willy-nilly here. Maybe with the same query replace regex type of thing. And we can replace vector push with what looks to be out into a group of things, followed by a closing paren. And I want to replace that with merpush. Please merpush. Just like that. Yep, this looks to be working just fine. Okay. Legendary. Nothing was printed. What happened there? I guess we have to pass. Why is this not working? What? Oh yeah, because we're not returning the vector here. This has to be like this. Because when we do this here, it's used on the left-hand side as an L value. And MIR is an L value, but only into this local, and we need it to be an L value into our actual one. Okay. Well, that's going to break a lot of things then. First of all, yeah, it's just conflicting types. So that's also going to have to be a vector pointer. And then everywhere I pass not a vector pointer to it, that's going to be a huge problem. So everywhere called out in machine ir.c is what they're complaining about. Well, good old query replace coming in handy today. So if we match on merpush out anything and replace it with merpush and out anything, it should be good to go. 14 occurrences, the legendary. And then now it's in the I cell, I have to do the same thing. So in here I called it mer, but it should be a very similar thing. Okay, that's much better. And now you can see we have vreges and vreges. Beautiful, beautiful, beautiful. Okay. So why is that helpful? Because now instead of having these references here, we can have a register, but it's just going to be this vreg. And then also vreges are going to have to start not at 0, right? That's also something we determined. So these are not going to be just size, they're going to be size plus the size tcast of my arch start. Perfect. And now, if we minus this number, we will get an index into this array, into this vector. How beautiful. Which means we can find an MIR instruction by vreg. And this is going to be MIR find by reg. And all we're going to say is assert that reg is less than mir.size. Well, first we're going to get the actual index and say that it is equal to reg minus mir arch start. And then first of all, we also are going to assert reg is greater than or equal to mir arch start. Invalid mir register. Yeah, so this is going to be vreg. Because this isn't, for example, defined it by, oh, find me a machine instruction that has racks. That's not what we want. We want it to just be these special vregs. So now we want to assert that the index is less than the MIR size, and MRI. Milaudy says the virtual registers have to be mapped to actual registers at some point, right? Yep, that's called register allocation. And that will happen after instruction selection. Because if we have one IR instruction get allocated a register, but then it gets actually instruction selected into 3 instructions, right? Then those 3 instructions may each need a register, and it's going to break everything. So this is what that's for, so that we can have one-to-many and many-to-one conversions. Okay. Invalid index. Return MRO.data plus index. That's why I've done this. This is fast. Yeah? Okay. Okay. So now, registered becomes kind of interesting. Because this is a hardware register, clearly. So instead of, when we have a reference here, when we have a pointer to another one, maybe we don't need that. Maybe we just use the vreg, right? Because then that can eventually be replaced by a regular reg. How much will that break? Not a ton. Okay, not a little bit though. It's like 20 places. Conflicting types for MIR operand reference. Well, that's going to be a major issue. So in machine IR forward, this also exists, which makes sense. So if an operand reference is actually just a register number, how many places would that actually break? Oh, 1 place. And it's where we're printing it out. Oh, there's so many warnings I have to fix. Okay, well, I think we can fix where we're printing it out. That won't be too difficult. Also, we don't need /b here anymore. I don't know why that didn't work either. Exhaustive handling of MIR operand kinds. It was in reference. We no longer do ref ID. Ref is the ID itself. And then that's going to be V. Okay, so now we're setting a pointer. We're somehow setting that from a pointer. Yeah, why is this not, huh? This isn't a type error? C. We're assigning to a size t from a pointer, and it's just like, yeah, that's allowed. No cast needed. What's up? Oh God. Rethai, thank you so much for the follow. Or Retal. I don't know how to say that. That's not gonna work. That's a little better. Craziness. Very cool. Very cool. I don't like these register. Why do we have register instructions? I don't feel like we should have register instructions because they can just be register operands. You know? Can we fix that? How can we fix that? That's got to be in the I cell. We are making progress though. This is actually working phenomenally well. Because we want to move from this register to this into here. But this is Does everything always go in a virtual register? Brain moment. Sure. Yeah, why not? Why don't things go in a virtual register? Why not? Yeah, it'll be fine. Yeah, that's fine. Yeah. Yeah. Who cares? Oh, okay. I know what's going on now. I know what's going on now. I don't think I need op reference anymore. And I think it should be part of OP register. And then what we should do is if value is not able to be a hardware register, it's a virtual register. But then we have to, well, that's what we want. Because we want them to share a namespace or whatever effectively. So this value is going to be a register. Okay, let's think about this. I'm going to go to machine IR forward, and I'm going to say we're going to get rid of these things. No more operand references. We shouldn't need more than like 60,000 virtual registers. If we do, I'm doing something wrong. So we have all these. Machine IR forward has all these. What's failing? What exactly is failing? Because we should fail in a few places. MIR operand reference ref, and it says, hey, that doesn't exist. So that's true. We no longer want to create a reference in this way. Because we want to create a register. I'm starting to get it now. It's all starting to come together. So everywhere we have MR reference, right? Every time we have one of these, what we are actually saying is that where it would this, right? But it's a register without a size. Do I just pass 0 and call it good? Do I pass R64? What do I pass here when I don't know the register size? Well, you have to know the register size, you silly man. And also, this isn't going to work because reference had the key code in it that handled references properly. In that, so I can't get rid of these. They're going to be doing different things. Because the key is that the reference is now just going to be the vreg, right? But it's not going to be in .ref anymore. I don't even want that to exist. So can I please get rid of that? please and thank you. Yeah, no more MIR operand reference. I don't even know where that type was coming from. Who knows? Right? And now, what did I break now? It says, okay, so now in machineIR.c, it's telling me ref does not exist, you're crazy. And that's true. Is egglet just not coming out to play? Yeah. Cool. So now what we want to do is set register to instruction register. And then again, I think I'm going to do something like this in machineIR forward, where I do type def. I'm gonna do the MIR register. And I think it can just be UN32T now for now. I don't think it really matters. I mean, it could really even just be like unsigned int. I think that's fine. Sure. And then in machineIR, I don't know why I repeat these. Why am I repeating these type defs? I don't know. Probably just for locality so you can see what they are. I don't think that's necessary. Can't I put the struct definition in there too? Like, why does that have to be a forward decal? We're gonna do this. It's fine, because each translation unit can get its own struct definition that's identical. I don't think that matters. Now when we say size t reg, we can actually do MIR register reg. Now whole bunches of issues, perfect. Unknown type name MIR operand function. Does that one not exist in forward? Doesn't. It just existed here. It's a great example of why you don't have things in two places. Okey-doke. Okey-doke. Much better. What do we have now? Ref. In iCell, we have machine.ir, machineIR.c. What do we have? We still have .ref in a few places, so let's just search for .ref in machineIR.c. It's here. Equals instruction, machine instruction, register. Really what I want to return here is the reference to the machine instruction. Okay, that cleans that up a little bit too. And then instruction register, is that still a size t? I didn't change that back after I undid everything. Again, just .ref in a few places. Okay. And we got rid of that little warning. Cool. There is no MIR OP reference. That's going to break a lot of things. Six. Right. Okay. machineIR.c has some more references. It's now a register. Those were the only two there. Now in iCell, we did a .ref somewhere. We get the operator of a load, and then assuming it's a register. So this is where we get to use our new fancy, what's it called? The function we just wrote, find by reg. Ain't that right? Didn't we just write that? Did I not put this in the header? That's probably what happened. Was this issue? Okay. It's add index. My bad. And what happened? We still have the .ref thing. I didn't change that. But I should be able to now. So from the first operand, register value, find by vreg, please. My thangalangus. Legendary. Legendary, legendary. Can I print those out? I feel like everything's red or blue. What would be a good color for these registers to be printed out as? It'd also just help if I didn't print out the size, I guess. Let's just do that for now. We'll leave the register size as something we don't need to expand upon for now. And we'll just print, I guess in blue like we were. It's a little easier to read, I'd say. Okay. We're doing much better. We're doing much better. So now we're still using registers, but we don't want to do this anymore. We want to find everywhere that says reference, basically, right? Or register. See, this stuff where it says value result, we don't want that anymore. And we actually want it to be a reference, which is again just a register, to the values machine instruction. Yeah? What does that take? Let's take a look at that. Okay. This looks very good. This is what I was going for. So now you can see that if it's not a hardware register, we can probably print R or V based on that and maybe do different colors. That's kind of a good idea. So if it's greater than or equal to R to start, we can do a V, otherwise we can do an R. Then maybe even put it in a different color. Is it purple? Purple's kind of bright. 37 is gray, 36 is cyan. Maybe like green. That's not bad. And then we'll flip them. So hardware registers are going to be in green, and then virtual registers are in blue. That looks very good. That looks very good. And then if we're going to have them be in blue, we should have them be in blue everywhere. Cool. Very cool. 1088. Way up there, huh? Very cool. So with all these immediates, I feel like numbers shouldn't be red either, but that's something we can get to now. Yellow seems weird. Purple might make sense for numbers. I think that, yeah. Sure, it's not ideal, but it's fine. It's a little bright. I wish I had like a lighter purple. But this is good. This is good. So now, I would love to get rid of these immediate. How could I do that? I guess that's, I'm going to wait for actual pattern matching in the instruction selection for that, because then we can just say, if you see any move instruction and the left-hand side is an immediate, or a register to register move, the left-hand side's immediate, etc. Okay, very cool. Very cool. So with this virtual register system, we can now reference things by their virtual register or not, which is very nice. Very nice. Okay. So what do we actually need to do? I mean, as of now, we could already emit this as code because we go to 1088 and it technically already has stuff assigned to it. The virtual registers here are never lowered. So how would I lower these on the left, right? I just have to go through and do register allocation. That's effectively what that means. Well, that's a good stage to be at. I think the machine code might be at a stage where we can start morphing register allocation to work on it instead of the IR, which would be very cool. Why is R1 and R5, why are these hard-coded? That doesn't seem correct, at least not yet. To do maybe print size. Okay. I'm looking more for OP register. Here's another place, destination register, and it should be a reference. And this is going to be a reference to myself. I don't know how that's going to work. But let's try that out, huh? So this is going to be move. And then we're going to add that to move. So the destination of some moves should have been should now be, what did I just do? Load from a pointer. I see. Also, this is still happening here. So this should be a reference as well to itself. Matthews, thank you so much for the follow. I appreciate it. So we should... Why are these not... These are stores and stuff, and Leah's. But we got rid of all that in stores. So when we have stored to a pointer, why do we have like R9? Oh, those must be Leah. And if those are Leah, what does that mean? Those are allocates, most likely. This thing needs to be a reference, again, to itself. Sally Prosper says hi. What's up, Sally? Thank you so much for the follow as well. I see that. How's it going? R0, that's not right. So because we haven't pushed it yet, we don't know its ID. It's a little sucky. That's not ideal. So if we get the second instruction from the allocate, the second operand, excuse me, can we then assign it to this thing again? After adding like a dummy one? Sure. Well, that definitely did do the trick. So now whatever this register, this virtual register gets lowered to, we also need to lower that to a non-virtual register. Does that make any sense? Hopefully this makes any sense. Vegan, 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 vegan says, hey dude, hope the compiler is coming along well. Thank you, I appreciate that. It is coming along very well. It's getting more complex, but it's also about to be so much more efficient, and optimizing is about to be so much easier. And it's getting good. It's getting good. I'm getting to the point where I'm nearly at the point where it's a real compiler. We still have R0 in this case, so we aren't doing that fake entry somewhere where we should be. So that really has to do with the destination being the result of the thing. And then we can say something like this. So it's really just these these self-referencing ones that really are the big deal. Like here. Move. Did I copy that from? Didn't copy the one it was from. It's just the destination register. Oh, it's just a reference to itself too. Okay, this is getting much better. Destination register is actually going to be fake entry. And then we will update that entry afterwards. Now that it has the proper thing. So we can reference it now that it's been added to or pushed to the list of machine instructions. Perfect. And this is a reference to itself again. How many of these do we have? That should be it. Okay, yeah. Much better. Much, much better. Not sure where I just went. There we go. Lots of virtual registers now. That's beautiful. So now you can see wherever 1068 ends up, that's where we want to end up moving this. Because we want to move this into the virtual register of this one. And this register operand here refers to that. So that's good. So that's good. And now when lowering or doing register allocation, when we replace this, we can go through, I guess we save a mapping and say like, oh, virtual register 1068 is actually racks or something. I don't know. Because then anytime we encounter an operand of virtual 1068, we have to replace it with hardware racks or whatever it is. I do have to go very soon, but I had a great time today. Oh my god. Is it true? I just got an email. It's true. Code review happened. Legendary. Okay, hold on. Sarade left a review. Legendary. Left off at Machine IR Forward. Big change. Approved. The single empty line. Yes. The single empty line. That's hilarious. I'd have left these tables in their respective headers, but I suppose they could also go here. Cogen forward was mostly intended for forward declarations to break header dependency cycles. Yeah, that's what this was for. As far as I know. Because, yeah. So what he's talking about is there's machine IR forward here. And cogen IR forward, or cogen forward or whatever it is, yeah. And what I've done is moved these all IR instruction types into the forward instead of into the actual header itself. And this was necessary, or is necessary, because machineIR.h includes machine IR forward. And machine IR forward includes cogen forward. And cogen forward and machine IR forward need to be enough to actually have the enums and stuff. So that in, or at least it was. I don't know if we need to do that anymore based on how it works now. But for example, to be able to define the MIR opcodes, then we also need this all IR instruction types. But if we included cogen itself, then that means that in cogen, we couldn't actually include machine IR.h. Hopefully that makes it more clear. It's for the same reason. This won't work with MSVC. Yeah, attribute packed. It uses a pragma for that instead. I would highly recommend something like packed. Okay. Yes. So we should make sure to handle that. I'm not sure the pragma version works. That, or we could just drop MSVC support. Yeah, that's true. Same problem here. Yeah, the cough code I actually copied from an older project, so that makes sense. At this point, you know what to do, Lamau. Here as well. Actually, is that? Oh, cough.h. What mode line is that? I wrote it. I don't know if you're surprised at that at this point. I wrote it. Xcoding, thank you so much for the follow. Hello, how's it going? But yeah, Nick Shell, I wrote it. It's available in my Emacs.files. It's terrible. It's the horriblest Emacs Lisp code I've ever written. And it's very slow. Just so you know. It's like, it's not a fast mode line. Xcoding says, doing well, how are you? Thanks for asking, I'm doing okay. I gotta go here soon, but I'm having a lot of fun. And this compiler is actually coming along. What am I looking for? Actually? Here. Perfect. More packed structs. Yes, still more. At this point, I'm just going to mark these 3 in one fell swoop. We should really be using span string instead of C-style strings. That would also help get rid of memory leaks because as we know to always free a string if it goes out of scope and isn't referenced elsewhere, etc. Yeah, that's true. I don't think it's a big deal, but that is true. I'm sure you can do some horrible stuff with generic to overload this if you're interested. Oh god. I'm fine. If the loop has a size of 4 that's known at compile time, I'm 99% sure the compiler's going to enroll it anyway. Not really. Because if it has a size of 4, but not if it has a size of a multiple of 4, or like what if it's 16 bytes? You still want to write 4 at a time, even if you can't unroll a loop. I don't think this is ever deleted. Very true, I'm sure. Pretty sure this vector is just leaked, probably also true. See, this is exactly what the Cogen forward header is for. A for declaration there would suffice, and then this header wouldn't have to include any MIR headers for this. Interesting. So instead of having machine IR forward in its own thing and then that included, you could also just move it into Cogen forward. That's also a possibility. I don't think it's really, it matters. This include can be avoided. I don't think that matters. Half of these use quote, the other, oh, is machine IR.c been mangled by Egglet? No, I fixed it. I've since fixed that. Does this play nicely with forward references, e.g. branches and files containing forward references due to loop code gen? Probably not. Yeah. Yeah, almost certainly not, actually. Almost certainly not. What is the solution to that? Do we need, like, relocations? So if we had, like... What he's talking about is this thing here, where when we reference an IR instruction from MIR as an operand, we actually need the machine instruction. But if we're referencing an IR instruction ahead of the current one, then it will not have been emitted yet. So what is this? What is the solution to that? Do we need like relocations and say like add to list of relocations and then afterwards fix up relocations? We could do that. That doesn't seem right though. So like we could just say if it doesn't have a machine instruction, then set it to some special value that says it'll be filled in later, and then go through and fill it in later. But I don't think is that really what we want to do? Do we want to go through and make sure that's done first? Do we need like relocations for forward reference? Or is there some easier solution? Genuinely curious. This is awesome. I'm glad we got a code review. This is fun. This murallic ID should probably be part of the code gen context. Why? swap the order of these two to reduce the size of the struct by 1 padding. I don't really care. I feel like this header doesn't really need to exist. All 4 declarations just go in regular code and 4 in the rest of machine on, unless I was to split these up into 2. I mean, they're just different things. That's the only reason why. But yeah, there's not major problems. The biggest problem is the packed attribute, right? And we know how to fix that. So I'll do that later. Because macro nonsense isn't really fun to work on, and it's especially not fun to watch someone work on it. Okay, cool. So now we're doing relatively well. A good question would be, does this program fully represent the actual program? I think it does. So I think one way we can test that is by taking a look at code.s. So we move a bunch of numbers into a bunch of registers, right? 1060 through 1067. Chris JW, thank you so much for the follow. I appreciate it. I cannot believe I'm almost at 550. That's insane. You are such an amazing community. Thanks for watching, everybody. Nick Shell with the follow. Oh man, we're going to be like 1 away. I don't even know how much I have, to be honest. I just remember it's high. I was at like 540 and I was like, ooh, I'm going to be 555 soon. It's incredible. But yeah, we're 2 away now. We're 2 away. I'm at 548. So awesome. But yeah, so now you can see we moved 1067 off of -8 on the base pointer. Why are we doing these loads? I don't think we need to do these. We definitely don't. I don't know why they're here. It's just an artifact of lowering, I think. But they're never actually used. But they are used, but we recalculate their values. That is a tough one. Okay. Anyway, this is looking much better. So as you can see, we have a bunch of immediates or something somewhere. And then we Leah -8 RBP RBX. So Leah's 1081, move is 1080. So we Leah -8 off of RBP into RBX, or 1068. And then 1068, when is that ever used again? Where is RBX used? Is it not? Why do we do that? We don't use it. That's what I was just going on about. That's right. And then the rest of these are just parameters. That's correct. That's correct. So yeah, the fact that these are parameters means they go in registers. So we don't even have to move a lot of them. And then these go on the stack, and that's what we're doing here. Okay. Okay. So we move -8 off the bin, 16, 32. And we move racks, which is 10. Yes. We move 7, 0, and 69. Oh. Yeah. Okay. And then that makes a lot of sense. Move R2 into 1077, which basically just says move R2 into wherever I am. So now I think I've got an interesting thing we can do here. Which is that we still have to fix the call. I know we're not doing a bunch of pushes and pops and stuff like that. So we copy these And then we make sure to set the lowered. I think I'm at a good point right now because basically I just have to replace virtual registers with hardware registers and we're good to go. So at this point it's going to be doing more of this, creating for all of the instructions the actual patterns. Because these are the MIR patterns. I know they just don't look very pretty right now. Eventually we should hopefully be able to say if you get an allocate, an MI allocate, then turn that into this list of instructions, which happens to be a Leah, right? An MX64 Leah with 3 operands, as you can see. The first operand is just going to be RBP. However we do that. Second operand is going to be the offset, the allocate offset. So that would be the operand of this, right? As far as I know. Let's try and get the offset from the actual machine instruction, because as far as I know in MIR from IR, we encode the offset. We encode the size, not the offset. I see. So the offset hasn't been encoded, which is why we had to kind of reach around into the IR. Okay. But yeah, so we'd have to change up MI allocate to actually include the offset, right? And then we could say like operand 1 and then this would be the destination register, right? So we'd have like some percentage dest or something like that. And then this pattern would equate to all this code. I just wouldn't have to write it, right? It'd be very nice. We're working towards this. That will be one huge thing for machine instructions. And then we're working towards also having like where operand 1 is MI immediate or something like that, right? And you can do matches like this and then get the first operand clearly. And yeah, that's the goal eventually, but this is where we're at right now. And I think we don't have any major glaring issues or cashews or tissues. Yeah, we don't have any major ones that aren't in the assembly itself, as in all these useless Leahs that we don't actually use. And then to actually do register allocation, it is going to be complicated, but it's not going to be too bad. We just loop over the instructions, keep track of virtual addresses that we've translated, virtual registers that we've translated into hardware registers, and then just replace the occurrences of those virtual registers in operands with the hardware one we've mapped it to. Or something like that. So that'd be cool. This is all seeming to work. Cool. So very soon we'll actually be able to emit code based on this list of machine instructions instead, which will be very cool. That'll be very, very, very cool. Why are we moving from R2 here? That seems a little suspicious. I see. There's still a bunch of these OP underscore registers I've got to fix into references, right? And then this is actually itself. This is another self move. And then we've got to assign this to reference itself. Here, I'll stay with the convention that I did before, legendary. That way it's easier to find in the future. Cool. We have way less hardware registers being encoded now. This is good. Also, why is this right-hand side? Is that correct? I feel like that might not be correct. That actually probably is correct because that's the value we're moving from, and we kind of have an intel left to right, right to left thing happening here. Like an assignment. Adder equals blah. This is the left, that's the right. Okay. Cool. R6. Register condition, or condition, I'm just going to call this condition. It's going to be a branch condition machine instruction reference. Nothing more, nothing less. Coolio? Coolio. Still not quite there. So source is going to be a reference to the operand machine instruction. That's better. And I know it doesn't make sense if you're familiar with all this. Like, why are you trying to get rid of hardware registers and replace them with virtual ones? Are you insane? But the idea is that register allocation won't have happened yet. At this point it has, but the idea is that we're going to move it until after, and to actually be able to do that, right? It's going to mean that we can't rely on register allocation happening in this translation. So the only registers that we should actually be using are, like you see now, hard-coded registers like the base pointer. Poggers. So now at this point, I guess, see, we still have register operands, but at this point, this is good. I'm Victor, thank you so much for the follow. I am not Victor, that's just your name. Oh, but so now what we're going to be able to do is loop through all this stuff and say this virtual register is equal to this hardware register, and if then, and then replace all the occurrences of that virtual register with it. Days VFX, thank you so much for the follow. And they say compiler dev? Yes, compiler dev. That's what we're doing. For a whole language that I made up. BB. We got rule 110. It's getting better. This is such old code. I don't think I'd write it like this anymore. Days VFX says, so you're the smarty pants behind all code. That's true, I created computers. I went back in time when I was 42 to 1960s, 1950s, told Alan Turing everything. I was like, hey man, I know it sounds crazy, but you gotta make this like whole room full of wires. And it was hard to convince him, but he eventually did it. Luckily, you know, I was able to let him know. God bless Alan, Mr. Turing. Cool. This is getting very good. This is getting very good. Let's start the IR call nonsense, shall we? I got scared off the IR call because of the epilogue thing. Yeah, call is quite a lot of stuff. I can see why I'm nervous to translate a call into all this. Days VFX. Wait, the IRS called? I hope not. The intermediate representation call instruction. Lol. Yeah, you didn't file your 1099 and you made $601. You're going to jail, boy. Okay. This is a mess. So how does an IR call get lowered into machine IR? I have to go. I'm not going to be able to do this fully, just so everybody knows. That's right. Arguments might be important to a call. Darn. Days VFX says, I didn't report to the CRA for 2 years. Just this year I did my taxes for the first time. I'm 18. Lamau. That is the nice thing with taxes, is you can be a year or two behind. It's not the end of the world. And a lot of companies operate like that on purpose, or ahead, or like the time frame doesn't matter as long as you're doing it, right? But yeah, I'm all caught up. I've done it every year. Just cause, why not? You know, why be in debt to the government when you don't have to be? Are you a dev as a hobby? Yep, I do it for fun. Yeah, this is not anything useful. This is a really bad lowering of calls. Days of VFX is awesome, thank you. I am winding down here. If you would like to catch more streams in the future, or maybe influence streams and when I stream, like Gmos today said, stream. Live when? And I said, yeah, sure, let's do it. And I'm streaming now, right? So be sure to join the Discord. You can have a direct impact on the lives of all these wonderful people in this awesome community. And if you ask for the @notifs role, you will be pinged every time I go live, or just by joining and checking out the announcements server, you can never miss another stream. I highly recommend it. And then also go to youtube.com/@LENSR Lenser for all the VODs of the streams that I have done up until this point in my life. There are like 10 days worth of video on that YouTube channel. There is plenty to watch if this type of content is your thing. That's my little spiel, because I'm near the end of my stream. If I don't say that, nobody will know. Days VFX says, oh god, I can't tell if this stream is real or not. Nothing's real. Days VFX, it's all a lie. It's a lie. Code is fake. Oh god. I'm kind of curious just to look at the register allocator at this point and figure out how much is going to need to change. I mean, clearly, we're going to have to loop over machine instructions, so that's going to be something that has to happen. Machine instructions instead of IR instructions. What does collect instructions actually do? It basically just collects instructions. Okay. Good to know. Good to know. So I couldn't compute that in my database. Report error code 9G0A to my manufacturer. See, the real false thing there is that there wouldn't be a G in a hex number. How would you print out a G? That'd mean you're doing... I mean, you're doing string literal hex number error codes. Error 943 4GX. Like, yeah, that's perfect. Just print that. There's no need to say, like, what the error was if you're printing a string. You know, just print that. So when we collect instructions, we collect all of the instructions. We build the adjacency graph. I'm pretty sure this works on control flow backwards. Yeah, we no longer do the dominator treeness, and we now do this thing. Not this thing. This thing. Collect interferences for function. Yeah, and then we walk the blocks backward to find the interfering values. Yes, yes, we do. So we find all the blocks that may exit the function. Which is a return or an unreachable. So this is the only way to exit the function. This may change with like tail calls and stuff. That's a little worrying. Another thing I'm worried about is that, like, we can't check if it's an IR return if it's a machine instruction. Because return may be like MX64 ret, or it may be like Arch64 ret. It may be any return instruction. I wonder what the solution to that is. I wonder what the solution to that is. Bop, 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 bop. I don't know. So if we want to know whether something's... Why do we need to know whether something's a return or an unreachable? We don't need to know this, right? This just needs to turn into a function that each backend implements that says machine instruction is exit, right? So to do would be like mir is exit opcode. Instead of explicitly checking opcode. Right? And that's probably going to have to be part of the machine description. Megabit, make part of machine description. Poggers. Okay, then we have live vals visited and doubly visited. For every block, we clear those, and then we collect the interferences from that block. I see. So if we jump from this block to somewhere else, and then we get back to this block again from another interference collection, then we'll say, oh, it's doubly visited. We don't need to do this. Not even it's visited. That would be it's visited. But then if we do that again, that means it's doubly visited. Why do we need to keep track of that? I don't know. Oh, because we need to visit blocks twice, otherwise we'll miss loops. Confusing. Okay. Yeah. Is this in Nano? Yeah, this is Nano. This is not in Nano. This is in GNU Emacs. And so is your chat. How about that? Cool. So to walk blocks backward, we're going to need blocks. So I think that MIR is going to have to gain the function block abstraction. Here, I'm going to write this down. Okay. What am I doing? What do I have to do tomorrow? Oh no, this is my bad pen. It's got like no ink. Okay, hopefully I can read this tomorrow. It's so light on the paper. It's like it's got ink, but there's just a thin line coming out at this point. What do I have to do, man? Okay, I have to add the IR function and, oh god, how do you draw an ampersand? There we go. An IR block abstractions to MIR. Okay. This will allow for control flow walking. Yeah. Because currently we don't have blocks or functions in the machine IR. We just have a big list of machine IR. And there's function and block instructions that are needed basically only for the shitty code gen right now to say, oh, there's actually a function starting here, add a label in the code. Days VFX says, it's actually funny I got that wrong. I was using Nano for my placement trying to get my chatbot working. Interesting. Yosebe 2, thank you so much for the follow. I appreciate it. We are over 550. We're at 551 now. That's so pog. Thank you everybody so much for watching. Okay, so yeah. So with this large list of machine instructions, you see we even have multiple functions in this list. We should at least split this into two lists per, like a list per function, right? So function main should be like its own thing, not an MIR instruction anymore. Or maybe it is an MIR instruction, but it just has a list of block instructions. Or something like that, I don't know. Yeah, it's almost 3, I gotta go. But yeah, this is all stuff I really want to do. I know today was a bit of a weird stream. It definitely wasn't the regular because Midnight 606, thank you so much for the follow. Legendary. This definitely wasn't a regular stream. I was in the middle of coding and somebody just said live when, and so I went live. And I think we had fun. And we got a ton done. Look at this MIR. Oh, let's actually commit stuff before I go. That'll be perfect. Okay, so this stuff is formatting. OGO1, thank you so much for the follow. Uint64, thank you so much for the follow. Shago, thank you so much for the follow. That's incredible. 3 in a row. 4 in a row. There has been so many follows. Thank you. I appreciate it so much. I can't believe I'm over 550. This community is growing so fast, and it's so awesome to see. Be sure to join the Discord if you never want to miss another live stream as well, because I make one of these announcements every time I go live in this special channel where nobody else can talk except me. Dagger, thank you so much for joining the Discord. It's so good to see you. Ooh, baby, a triple, says Tiki. It is. It is a triple. OGO1 says, you're making cool stuff, so I need to follow. Oh, thank you, man. I appreciate that. Hold on. Why is all this in here? All this shouldn't be in here. Why is all that in there? Hold on. Hold on. Did I have stuff? Why? What happened here? Just that one, please. I thought I did that before. Maybe I'm crazy. Get you... Rexays, thank you so much for the follow. Oh my god, that's incredible. There's so many people. Days VFX trying to hack ERC, apparently. What have I done? That was confusing. Does anybody know what just happened? Two of them opened. I pressed Control C. Okay, there we go. That one worked. Okay, now there's so many changes. Machine IR has been like this. I don't think I can actually even keep track of all these. I'm just going to assume they work. So I'm going to just add that missing Rex byte. That's right. That is one thing I did. I do know that'll work fine. Fixed that bug, so I can remove that. Actually, I can discard that hunk. Gitchvuxt says, nice stream. Thank you. I like your name. It's really hard to say. Fix encoding of immediate to reg form of move. What else did we do? What else did we do? All the machine IR stuff. Yep, we're just gonna do literally all the machine IR stuff because I'm not doing that. Gitchvukt says, you don't read chat, do you? What do you mean? I read all of your messages. Did I miss one? Did you ask a question earlier and I didn't see it? That's very likely. I do that. Days VFX, can you stop trying to hack? It's really, you're not being a part of the conversation anymore. It might have been funny once or twice and actually relevant, but it's not anymore. It's just annoying. You got to be respectful of everybody here. Share the chat box with everybody else. MIR. Lots of changes. We are slowly working towards having an MIR that fully represents the program, at the same time being closer in representation to the underlying ISA that we will be emitting code for. From here, there's lots of complex stuff to do, like moving register allocation to MIR instead of IR. And all of that only once we have... Oh, and also pattern matching for instruction selection using a DSL or something would be glorious. That's hard to read. There we go. We're slowly working from here. There's a lot of come like instead of iron, and also glorious. Perfect. Days VFX says ERC. That sounds familiar. The Emacs IRC client. Perfect. My 3 changes. That's right. That's right. Machine IR forward was recommended. Okay. Cool. I'm gonna go to the scratch page. I don't have time. All right, we're winding down. Tiki says, what is the best way to learn low-level systems programming? I don't understand much as a noob web dev, lol. Well, if you don't understand something and you want to understand it, I would say attempt to understand it. And I know that sounds stupid, but it's true. Tiki, what don't you know? If you don't know what you don't know, then just go looking. Go look at C code, right? Go say like, let me look at something. figure out, right, explore. And then you'll run into stuff that you don't know, and you'll go, hey, I don't know that. And then you look that up and you figure it out, right? My goal, what works for me, is to learn new things, is to keep the goal, like, as your motivator. So when I am working on a program, I go, I'm going to get this to work. And then I write code to get that thing to work. Even if the code is horrible, or even if I know I'm doing the wrong thing, and I'll have to fix it later, right? You can at least get something working, and that feels good. And that helps you move forward. Rexays, thank you so much for the follow. Pos420 says, learn C. Lol. But yeah, Tiki, so pick a project. What's something, why do you want to learn low-level or systems programming? What is a project that involves low-level or systems programming that you want to work on? Do that. Seriously, like if you're like, I don't know, I want to learn about servers, then that's awesome. Go learn about the low-level how servers work, and literally just Google the word how servers work, right? And then you'll go from there. But just pick a project and then do it, and do it in a low-level language. If you want to learn C, write code in C, right? Because it's pretty easy to go like, okay, open up a file in a text editor, and that's like, and write something in it, right? You could do something as simple as this, right? Then figure out how to run this program. How do you actually get the number 69 to show up in your terminal, or something like that, right? Or maybe write a hello world, or look that up. How do I write hello world in C? And then just write that, compile it yourself, and run it. Define exit nice 69. Yeah. But yeah, Tiki says, that makes sense, thanks. Alrighty. Hopefully that helps you. There is plenty for you to do. Mr. Koter says, Arduino C code project can be fun. Use sensors and motors. That can be a ton of fun. It's definitely more costly and takes more time. But if you want to spend some money on it and have some fun, yeah, definitely. Get some hardware. Do some embedded programming. Days VFX, you have a nice personality. We'll def be stopping by stream as much as possible. Thank you, Days. I appreciate it. I appreciate that so much. I have fun streaming, so I'll be stopping by this stream as much as possible as well. Lisa Botzi, thank you so much for the follow. I gotta look into... Why did... You don't read chat, do you? What happened? Gitch. Vuxed. Neglected. Oh, okay. Which type system have you implemented? Is it, I don't know how to answer that. I probably read that when I saw it and went, I don't know how to answer that, and just moved on. Pos420 says, oh yeah, what are we working on today? Well, we're not working on anything now. We were working on machine IR instructions. I am just ending the stream now, getting to... Oh god, you can hear I'm losing my voice too. I've been going for so long. We just got to the point where our IR, right, this stuff is being lowered into MIR, and we have actually been able to remove all the hardware registers and stuff like that aren't hard-coded, which means that this MIR can actually properly be operated on. What architecture is that? x86-64. I don't know what you're asking, but that's what architecture I'm on. This isn't an architecture. This is just my own IR language, right? The intermediate representation of my compiler. But yeah, as you can see, we then take this MIR, this generic MIR, and we lower it. Pos420 says, I thought it was assembly. Yay. Well, that's because it's MIR. Hypothetically, could I make a game with your language? You could make anything you want in Intercept. And there's even an SDL example. So yeah. You can use SDL and make a game. Do that. It'll be fun. Yeah? Why not? Why not? You could do it. I promise. And I can really clean up this SDL example now that we have early return. Because we actually have the return now. Days VFX says super cool. Thank you, thank you. I appreciate it. POS 420 SDL, yay! What's your opinion on the book Crafting Interpreters? I didn't read it fully through. I've definitely read sections of it, and it's got great information in it and data. Personally, it's not a great resource for me to like learn things from, just because of how it's written and basically just personality stuff, right? How I learn differently than that person assumes I would, right? But it's got great information, and I've definitely learned some stuff from it. So if you're looking to get into compilers and you read the first chapter of Crafting Interpreters and it's like, oh, this is awesome, I want to read more, do it. Read it all. Because there is great information there, and you're not getting like, you know what I mean, spoon-fed bad info. At the same time, I don't prefer Crafting Interpreters because people call it a compiler book. But it's like, it's really focused on the interpreter part. And also, locks is a very specific type of language, and it can be hard to kind of map what you learn about locks. What about the Dragon book? That's the opposite. It's way too heavy into compilers and not enough into like the abstract or the interpretation or the execution. So it's like you get like 20 new words per chapter, and they're all never used again. And then it's so complex. I'd say the Dragon book is so complex that it's like you don't need that much information. You don't need to know that to do register allocation, you need a web, and a web is this thing, and then this, and you get on all these side tangents, and then you get into like optimizations, and it's like, if all you want to learn about is how to add two numbers, Dragon book is POS 420 says, what's a good middle road for a learner? I don't think there is a good middle road book for learning compilers or compiler design or stuff like that. I think it's all either aimed way too low or aimed way too high, or just invalid information. Like this, like the kaleidoscope tutorial. It's terrible. Days VFX says, y'all know way more than me. I have no clue what y'all are talking about, lol. I don't think it's that we know more than you. We just know different stuff than you. Because I'd venture to say that you, Days VFX, know a lot of things that I don't know as well. So we don't necessarily know more than you. We're not like, right? We don't have like a million things in our head that you don't have. You just have a million things in your head. Days VFX says, I just like making games. That's awesome. I made games at one point. Do you use Unity? Do you use like Python and TK? What do you use? What's your style? POS 420 says, I'm currently learning C++ by doing an SDL game. Nice. Yeah, that's a good time. Graphics programming in C++ is not like a good place to start necessarily, but if you're able to and have fun doing it, that's more power to you. Do I trust my computer or do I trust my phone? They're like 5 minutes apart. But yeah, POS 420, I'm definitely interested in hearing about your game. Same Days VFX. Do you have like an itch.io? I already have a decent grasp of C, so I'm pretty comfortable in C++ already. Nice. Yeah, you'll definitely do fine then. You will definitely do fine. POS 420 says, my game is nowhere near completion. Days VFX says, Unreal Engine, haven't started learning C++ yet, but I have learned Python before. Was I good at it? No, but I would love to learn languages. You can, I promise. And I don't think anyone's good at Python. Can you be good at something bad? No, I'm just kidding. Tiki, thanks so much for the follow. I can't believe 558. 558. That's insanity. Thank you everybody so much for being a part of this. What's worse, Python or JavaScript? JavaScript. Python I've found to make it easier to do web design, but other than that, I don't know. Pos420 with the follow, thank you so much. Python's fine. JavaScript's fine too, it's just how it's used that sucks. JavaScript definitely has some language level flaws though. That, yeah. JavaScript is fine, kind of like how the person yelling because they didn't get what they want at the restaurant is fine. It's like, I mean, they can do that, but I would never do that. JavaScript is only terrible at chatting with your computer on a hardware level. Yeah, so doing computation. I agree, JavaScript is only terrible at doing computations. That's it. It's a programming language, so, you know, that might be important. Pos420, I just wish the backbone of the internet was something sturdier. Oh my god, right? Well, the scary part is learning that nothing is sturdy. You can write a C program that never errors. It's been running for 10 years, and it's got 80 memory leaks, and it's got huge errors, and it's got out-of-bounds memory accesses, and it's like, how has this worked for so long? It's like, oh yeah, we're just lucky. The OS that we're on kind of allows for that stuff to happen, and it doesn't crash, so... It's like, it's scary. Like, Microsoft is famous for that. DaysVFX says, if it works, don't touch it, Lemafau. Like, if you do a use after free in Microsoft, they don't reclaim or overwrite the memory that you free. They don't scrub it. So because there's no scrubbing, and they don't really reclaim it unless you do, like, huge frees and huge allocations, that means that you'll never notice if you use after free on Microsoft. Whereas on Linux, it, like, segfaults and is a huge problem right away. Pos420, I have such a respect for people doing big things in C. That's basically all I do. I have an OS, I have a compiler, I have a text editor. They're all in C or C++. I like doing big projects. Pos420, yes, low-level goodness. That's right. All right, everybody, I've had such a great time. It's been opinion on Rust. I mean, it's a fine language. It's a fine language. It's not my language or one that I will use because I can't. C is greater than star. What is star? Learning C++ is probably like the cheddar of the coding block. What? What does that even mean? What are you on about? Pos420 says glob. Ah, it's a glob. Oh, yeah. C is better than everything. C is greater than all. The Mao. Well, with that being said, thank you all so much for watching. Be sure to join the Discord if you have not already. You'll get announcements every time I go live. This is not just something I say. There truthfully is announcements for every single compiler part I've ever done. You can search for part 52, 51, 50. It's infinite, okay? I promise they're all there. What's good, gamers? What's up, Degar? Oh, Victor, thank you so much for joining. I appreciate it. Be sure to be like Victor and be a part of this wonderful community. We like Victor. Be like Victor. Other than that, if you're not into the Discord thing, I understand it. You can go to youtube.com/@LENSR and you will see my VODs. Every single stream that I've ever done has been uploaded here. There's like days worth, right? We have playlists. We have playlists if you want to see every video ever in the compiler that I've done. It's all here, so be sure to check it out. and subscribe on the YouTubes. So yeah, be sure to check that out. I've got something to look at. And from there, check out the GitHub and Codeberg. I've got things like the compiler itself, right? I've got an OS, which I think you should also check out. It's very cool. It's an entire OS. And Light, a text editor, and also a bootloader, and also a ton of other projects that I have fun working on. So be sure to check these out. Thank you everybody so much for watching. Check out the YouTube, check out the GitHub, star the projects, clone it, build it yourself, do all the cool things. All of you are amazing individuals. Every single one of you has the potential to change the world. So go out there, write some programs that return 69 and do good in this world. I promise you can. I'll see all of you very soon. Next time on this stream, be sure to follow, do whatever you need to do to make sure you can get back here. That's my spiel done. Thank you so much, Pause420. Shout out to Suraid for the old instruction selection branch that inspired this machine IR nonsense. Days VFX, I'm Victor. Rohan, who'd we have in here earlier? Tiki, we had... Who else? Gitchvuxt, which I accidentally ignored his question about type systems, Xcoding, Melody, Doplin. Oh, Ruark we had in here earlier. They're in here all the time. Be like those people, because those people are great people. Anyway, I'll see you next time. Do whatever you need to do, and stay fresh and stay clean, friends. Bye-bye.